Hello everybody. Well, today I'm going to show you how to do a portfolio optimization in Excel using Solver. And so to do that, we're also going to do a little bit of matrix notation, which makes our life a lot easier. So as a reminder of how this works, you're going to need to calculate an expected return for every portfolio optimization you do, and you're going to need to calculate a volatility, and this is actually the variance right here. But the expected return using matrix notation is going to be a weight vector transposed multiplied by a column of returns. And then here you're going to do, for the variance, you're going to do a weight vector transposed again times a covariance matrix times a weight vector not transposed. And then to get the standard deviation of that, of course, you'll take the square root of all of that. This will become more obvious as we go through this. You'll see what we're doing. But that's kind of the setup. That's what you're going to need to calculate. And you're going to ultimately want to do things like maximize return given that volatility target, or minimize volatility given a certain expected return target. So clearly you're going to need to forecast or calculate both of those. So to start off, what I'm going to do, let's just set up the problem. I've got 6 assets here, and then they're all stocks. So it's Oracle, Microsoft, IBM, Apple, Amazon, and Tesla. And what I have is I have a bunch of expected returns for them. And how did I get these numbers? Well, I didn't do anything all that sophisticated, unfortunately. All I did here was calculate historical returns from the years 2016 through the years 2020. I took those 5 years, I took monthly data, and so 60 months monthly data, and I just took the average return over that time period to calculate both the expected return and the standard deviation. Now, the reality is you should never do this. You should never use historical returns to forecast the future, particularly when you're looking at stocks that are all pretty much in the same or similar sectors. At least they're all heavy generators of technology. You should have tighter expected returns, because the problem with portfolio optimizations is they are great at error maximization. If you have small changes in expected returns, you get big differences in portfolio allocations. And so we'll probably see some of that today when we do our optimizations. Nonetheless, all I'm really trying to show you here today is the mechanics of how to do Solver. And so, let's just take it on faith that these are true expected returns. The volatilities, I'm using historical volatilities to kind of forecast the future volatility. And over here, I've got a covariance matrix. So as a reminder, what a covariance matrix is, I've got 6 stocks. So it's 6 by 6. It's a square matrix. It has the same number of rows as it does columns. Along the diagonal elements are all the variances. So that is the variance of Oracle, and this is the variance of Microsoft, and this right here is the variance of IBM, and so forth, Apple, Amazon, and Tesla. On the off diagonal elements, these are all covariances. So this is the covariance between Microsoft and Oracle. It happens to be 0.00142. This is also the covariance between Microsoft and Oracle. You can see the intersection there. So it is symmetrical. You will see that this number is the same as this number. So it is a symmetrical matrix. I show in another video on this channel how to calculate a covariance matrix. So, please check that out if you want to know how to generate this also using historical returns. I've got that on there. I won't go through that here today, so just take this on faith that this is the true covariance matrix. And now we've got everything that we need to start doing our problem. So the first thing we need to do is we really need to set it up. And so we've got, I started off with a very simple case where, well, let's create an equal weighted portfolio, not even optimized. Let's just do it on our own. Let's just say we've got 6 stocks and we put 1/6 in each. So you can see it's 1/6 up here, 1/6 equals 16.67%. Let's just verify by summing those up that this equals 100%. So that's a good thing to know. Like, what do my weights add up to? They should always add up to 100%, and they do in this case. All right, so what's the expected return of this portfolio? Well, really what I need is a combination of these weights and these returns, and I need to add it all up. Well, we're going to do our simple matrix notation here. We're going to take the weight vector, transpose it, and multiply it by the return vector. So how do we do that? Well, we're going to hit equal, and you can follow along up here, my numbers that I'm putting in and letters. So I'm going to hit matrix multiplication. So I'm telling Excel that I'm going to use matrix multiplication. And what I'm going to do is I'm going to transpose that first weight vector. So you typed in the word transpose, and Excel, it's a special command that Excel knows about. And it says, okay, let's transpose this vector, this column of numbers, this vector right here. Let's transpose that. And let's multiply that times this return vector. And let's close that off. And now I have to hit Control Shift Enter in order for matrix multiplication to work. You always hit Control Shift Enter. So you hold down Control Shift and then you hit Enter, and there you can see 2.7841%. The standard deviation, well, first we'll calculate the variance, but you can see I'll break this up. First, let's do this part. I'm going to do the weight vector transposed times the covariance matrix. And then once I've got that, then we'll multiply it by the weight vector again, not transposed. Okay, so again, let's go ahead and say, okay, Excel, we're going to do matrix multiplication, just a little heads up. So given the heads up, let's do that weight vector and let's transpose that. Oops, first let's transpose it. Let me put in transpose here. And we're going to transpose that weight vector. Okay, now let's go ahead and put in this covariance matrix. So I just highlight all of that, okay? And so far we've kind of got the first part of this done, right? Now we've kind of really basically got this part done. But now I need to multiply all of that again. I need to do matrix multiplication again and multiply that all by a weight vector. So I actually need to come up here and say, by the way, I'm going to do matrix multiplication one more time, Excel. And I'm going to take all this stuff that I did before, and I'm going to come over here and multiply all of that by this weight vector. And now I'm going to close that off, Control Shift Enter. Now it gives me this low number. I don't really have a standard deviation yet. I actually have a variance. I've calculated that, so it's squared. You can see, right here it is squared. So that is a variance. So what I need to do is I need to unsquare it, or i.e. take the square root of all that. So let's go back over here and say, hey, all that stuff that I just calculated, let's actually take the square root of all that. So let's go here, oops, SQRT. So again, that's a special command that Excel knows about, square root. You close this off now, and guess what? You got to hit Control Shift Enter one more time. Now I get 6.643%, and I also can get the information ratio by taking this number here divided by the standard deviation. That's all going to come in handy later. So I've kind of set up the problem here. What I'd like to do is, this is the equal weighted. Now I'm going to use Solver to calculate these three columns over here. So the first thing I want to do is I want to drag over my weights just to give Solver kind of a starting point for my initial weights. And this is what Solver is going to do. It's going to calculate the weights to solve the problem. Now, what I'd like to do is I need to drag this over too. The problem is, on the expected return calculation, is it wants to reference, it's always going to need to reference this column, B4 to B9. It always needs to reference that exact column. So I need to anchor that when I drag it over. So I'd like to highlight the B4, B9. And if you hit F4 at the top, it puts a $sign in front of everything. And that means it's anchored. Now, by the way, I can't just hit Enter again. I got to hit Control Shift Enter. I know it's annoying. You got to do it though. Control Shift Enter. And let's, by the way, down here on the standard deviation, I'm always referencing the covariance matrix. So I've got to anchor that too, and that is M4 to R9. So let's highlight that and hit F4. Bingo. Got a couple $signs, looking good. I'm okay with not anchoring the G columns because that's the weights, and I've got the weights over here, and so I'm okay with that. Those G's turn into H's next when I drag it over. You'll see what I mean by that. So hit Control Shift Enter. Yep, got to do that again. And now let's go ahead and drag this across. So let's just check this out. This is now referencing this weight vector here, which is great. It's referencing these H's, but it's still referencing the same old B return column. So that's great. And then down here, again, it's referencing the H column, my weights, and these weights, and then, but it's still referencing M4 to R9, which is my covariance matrix over here. So I'm looking good right now. So let's set up Solver. All right. So how do we do Solver? So you go up here to the top and you hit Data, and then over here to the right you'll see Solver. So you want to click on that. And I've already done a problem in here, so let me just clear it all out and just hit Reset All. Okay. Now, what Solvers wants me to do is it says, okay, here's the deal. It says you've got a few options. You can either maximize something, you can minimize something, you can actually target an exact value. In this case, what do I want to do? I want to maximize my return. I want to maximize my return subject to a constraint that the standard deviation is 5.278%. The reason I chose 5.278%, that actually happens to be this volatility number here, and if I scroll over a little bit more, you would see that that's Microsoft's volatility. Microsoft has a volatility of 5. Actually, let's go ahead and check that out. Microsoft has a volatility, and it's rounded here, but it's 5.278%, and it has an expected return of 2.6%. What I'd like to do is I want to know if I can do better than that. Can I get a higher return for that same level of volatility? Okay, so by using diversification and optimization, give me some better weights. So let's go ahead and do that. Let's say, hey, I want to maximize this return calculation. So this cell right here, I want to maximize that number. Okay, so you can see it's H14. How am I going to do that? Well, I'm going to do that by changing these cells. So that's what I want you to calculate. I want you, Solver, to solve those numbers for me. Now, what constraints do I want to do? Well, I want to constrain volatility to be 5.278%. So let's add in that constraint. I want my calculated volatility, which is this number down here. So it's H15. I want it to be less than, let's go less than or equal to 5.278%. That targeted number. I could type in 5.278% if I wanted to, but I like to reference another cell. Then I'm going to add another constraint. The other constraint I want to add is I want to make sure that the sum of all these weights is going to equal to 100%. So let's just hit this. I want this number to equal 100%, or same thing as saying I want it to equal 1. Okay. I could put in a long only constraint here too if I wanted to, but for now I'm not going to. So I could constrain the weights to all be greater than or equal to 0. I'm not going to do that. I'm just going to let it rip and see what we get. Okay. And it says, oh, you got a solution. Great. And it gave me some really different numbers, doesn't it? 85% in Microsoft. And it wants 6% in Oracle, or 6.7%, a little bit in Amazon, and a little bit in Tesla. Now it gives me that volatility. Bingo. It knocked it down to 5.278%. That's exactly what I wanted. And it gave me a return of 2.717%. How does that compare? It's better than over here. Over here we got 2.6% and that same level of volatility. So I've improved it. I've created a quote-unquote better portfolio, assuming, of course, that all of this is correct, and garbage in, garbage out, all that whole thing. We want to make sure that we got good expected returns in there. But overall, if these are true expected returns and true volatilities, and that's the true covariance matrix, then this is definitely a better portfolio than just owning Microsoft in and of itself. And so I'm happy right now. I've been able to increase my return. All right, now let's try something else. What if we want to instead say, what I'd like to do is I want to minimize risk. So minimize my standard deviation. And I want to do better. When you did that equal weighted, that really naive equal weighted portfolio over here, and you got this 2.784% expected return. Can I get that same return, or even better maybe? But at the same time, let's see if we can get a lower risk number than that. So let's minimize. What's the lowest risk number I can get, but still give me that same return? So it's a little bit of a different problem. So let's go into Solver and try this. And so let's reset all, right? So we're going to do a minimization now. We're going to minimize. You got to click that minimization number. I want to minimize. Oh, before this, my apologies. We got to copy everything over. So we got to copy this over here. And let's just go ahead and do it for both I and J so we don't have to go through that twice. But we're in column I right now, so let's go back into Solver. And I want to minimize. I want to do a minimization problem. I want to minimize this volatility number here. So that's that number there, right? So I'm going to minimize. Let me make sure we understand this. I want to minimize volatility. All right. I'm going to do that by changing these weight cells. I'm going to add a constraint here. Well, first of all, we know that's got to equal 1%. So we got the weights have to equal 100%. The weights have to equal 1 or 100%. Okay. And then what else do we want to do? Oh, I want to make sure that I want to minimize standard deviation, which is this number here, subject to the constraint that the return is greater than or equal to 2.784%. So I want this calculated return number to be greater than or equal to 2.784%. That's my constraint up there. Okay, and I'm going to hit OK. And let's just solve that. And it says, oh, it found a feasible solution. So that's good. It's not a whole lot different than my last solution. But let's just check out, see if the numbers work here. The expected return did land at 2.784%, just like it did over here. But wow, I cut my volatility down pretty significantly from 6.6% all the way down to 5.384%. So I got a much better portfolio just by diversifying just a little bit out of Microsoft. Now, what's interesting here is that even though all of these stocks have a higher volatility than Microsoft, I can still keep the same volatility by moving out of Microsoft. That's the interesting thing about diversification, is when correlations are less than 1, you can diversify and sometimes even lower your level of volatility. So I was able to keep the same level of vol as I was with the equal weighted portfolio, but get, the same level of expected return as I was with the equal weighted portfolio, but I was able to get a much lower volatility. So that makes me really happy right now. Okay, I'm thrilled. All right, so let's do one more deal here. Let's do one more. This time we're going to maximize the Sharpe ratio. It's technically not a Sharpe ratio. A Sharpe ratio is expected return minus the risk-free rate over the level of volatility. We're actually going to, I should call this an IR, it's an information ratio. We are going to maximize the information ratio, which is just the ratio between the expected return and the standard deviation. So I want to see how high I can get this number. So let's do Solver one more time. Let's clear out all of our historical problems and start from the beginning. So what I want to do, I want to do a maximization problem. So let's maximize that number right there. Okay. Now I don't really have to constrain anything. Well, first of all, let's say, okay, obviously we're going to change these weights. I do want to constrain the weights to be 100%. So let's add in a constraint where we say that has to equal 100% or just the number 1. The reality is I don't need to constrain on volatility or expected return, because all I'm doing is saying I just want the highest information ratio I can get. So let's go ahead and, one other thing we could do, I'll tell you what, let's add one more constraint. Let's add a long only constraint. Let's add one more constraint, and we're going to say that all of these numbers here, every single one of those numbers, has to be greater than or equal to 0. So nothing can be negative. Now, nothing has been negative so far, so maybe it's not a binding constraint. We'll test that proposition in a minute. Let's hit OK and let's hit solve. and hit OK. And wow, it's really three similar answers here, which is very rare. You usually don't get that, but we're getting very similar answers here. And but again, the information ratio here looks like it's the same. I'm guessing rounding error means it's marginally higher than it is over here, but looks like we can't really get a higher information ratio than 0.52. But again, it's better than anything we see over here on a single asset basis. So we're pretty happy with that answer. Let's double check that the long only constraint wasn't binding. So what we could do is go into solver one more time, and we could actually remove the long only constraint. So we can just kind of click on that and hit delete, and now just hit solve. And it may give us the same answer, and it actually does. It looks like it gives us the same exact answer. I'm not seeing any negative numbers here. Again, a lot of times if you don't have a long only constraint, you will see some negative numbers. You can imagine if I had some returns over here which were negative. Let's say I had like, you know, some stock, I don't know, just make up any stock that had like a minus 2% expected return and had a really high level of volatility. You can imagine that the solver may want to short that stock and put extra proceeds into other stocks. And so you will see that from time to time. You'll see minus numbers. And it's not everybody, not every portfolio can short stocks based on all the institutional guidelines against shorting stocks, depending on what kind of portfolio you're managing. So if that's the case, you're definitely going to want to have the long only constraint on there. You're going to want to make sure that none of your weights can be below zero. So anyways, I hope this is a good tutorial for you. I do produce a number of videos making finance fun for students. So if you enjoyed this video today, please like it, or please feel free to subscribe, and I will continue to put more content out there for you over